Hi guys, so this video is the final video in the series of chain and product and quotient rule questions. In this video we shall focus on the advanced concepts or the problems that came unorthodox. You are not used to this type of problems, so these are the more concept-based questions that you are likely to meet in your past papers. I shall begin question 1 shortly. So the first question we are going to tackle in this video came in paper 1, May 2017, time zone 2, question number 6. Kindly take a minute to look through the question and attempt to solve before I start my answer. So now would be a good time to pause the video. So for question A, we were required to find h of 1, where h of x equals f of x times g of x. So to find h of 1, I simply substitute x with 1. So in this function I have x, I'm just going to substitute that in my green function here with 1 and translate that into the rest of the expression. So instead of f of x times g of x, I have f of 1 times g of 1. Now, where can I find the values of f of 1 and g of 1? Well, you should know that f of 1 is actually the value of f of x when x equals 1. So that value is the 2 right there. What about g of 1? Again, that is the value of g of x when x equals 1. So the value is 9. I simply insert these two values into the equation and I multiply to get the value of 18. Now for question B, I am required to find h dash of 8, where h of x is the product of two different functions of x. So I should understand from that I should use the product rule right there in front of me. And the product rule is used when I have two different functions of x. I call the first function u, so f of x we shall label u, and the second function g of x we shall label v. Using these notations we can rewrite h dash of x as fg dash plus gf dash instead of uv dash plus vu dash. So all it takes here is to translate the u and the v that we are used to into f and g. Now that I have this equation, I need to just substitute the values in the formula from the table. So I have f of x when x equals 8, because in question B we want h dash of 8. So I'm looking for f of 8 right there. So what is f of 8? F of 8 is 4. F of x when x equals 8. What about g dash of 8? So g dash of 8 is g dash of x when x equals 8. So that gives me 5. So the first component is 4 times 5. So what about the second component? G of 8 times f dash of 8. Again, that's the same idea. G of 8 is going to be 2, g of x when x equals 8. And f dash of 8 is negative 3, where f dash of 8 is f dash of x when x equals 8. So I have 2 times negative 3. I multiply and add to get a final answer of 14. So maybe take a minute to write this down if you will. Pause the video. I'm about to begin question 2 shortly. So the second question that we shall tackle in this video came in paper 1, May 2012, time zone 2, question number 10. Take a minute to look the question through, try to solve, and now pause the video before I post the answer. So for question A, we are required to use the quotient rule to differentiate this function, showing that the final result has to look like this. Now let's walk through the steps of how to do that really quickly. Here is my original function in black. I first use the quotient rule, vu dash, so there is my vu dash minus u v dash over v squared. Then I simplify a little bit, so for the first component of the numerator I have an expression multiplied by 1, so I just remove the 1. For the second component I have x multiplied by negative 4x plus 5, so I just turn that into negative 4x squared plus 5x right there. And you notice how I used brackets extensively so as not to confuse the negative sign of the formula with the negative in negative 4x squared. So watch out. Now the third step involves simplifying the orange expression a little bit to reach the green expression right there. All I did here was I distributed the negative sign over the second bracket, getting positive 4x squared minus 5x. And the final expression is obtained by simplifying the numerator of the green expression, and you get 2x squared minus 2 over the squared bracket in the denominator. And this looks exactly the same as the required. Right there, the required function looks exactly the same as our answer. So moving on to question B, I'm required to find the coordinates of point B, which is the local maximum of the function. So we should know that the local maximum is a turning point, and hence the derivative function is equated to 0. This is what I did right here. I know that the maximum point means that f dash is equal to 0. Hence I equate this red expression to 0, and since it is a fraction I only need to equate the numerator to 0 because 0 over anything is 0. So 2x squared minus 2 equals 0, some simple algebra right there, and I get that x squared equals 1, and hence the possible values of x that satisfy this equation are 1 and negative 1. So why is the choice that I made negative 1? Simply because there is another point in the question that has the x coordinate of 1. So right there, point A has the x coordinate of 1, and point A is a local minimum, so the same rules apply. F dash equals 0, and I find the x value. So I have 2 points that are turning points, A and B. The x coordinate of A is 1, so the x coordinate of B has to be negative 1. So in order to find the y coordinate of B, I have to plug the x into the original function, f of x. So I'm going to plug negative 1 into the black function at the top, getting this red expression right there. I simplify it a little bit until I reach the y coordinate, which is negative 1 over negative 9, which also of course equals 1 over 9. Hence the coordinates of B are negative 1 and 1 over 9. Take a minute to look through the answers of questions A and B, a little bit slowly maybe. I'm about to start question C shortly. So question C says that the line y equals k does not meet the graph of f. The line y equals k does not meet the graph of f. I need to find the possible values of k. So this is a concept question, and this question in particular, this part C, is the reason why I classified this as an advanced problem, because not everybody really understands or easily grasps how to approach these unorthodox questions. But luckily you only have 3 marks out of 16 dedicated to this part, so you have 13 marks that are rather easy to obtain in this question. Anyway, let's focus on the drawing, the sketch, in order to explain how to find the values of k. So we are told that we have a line y equals k. You should know from previous years that the line y equals k is a horizontal line. Y equals anything gives me a horizontal line. So we are told that there are some horizontal lines that do not meet the graph of f of x. Let's try drawing some horizontal lines to see which ones meet the graph and which ones don't. So if I draw a line right here, does it meet the graph? Of course it does. It cuts the graph twice. Now what if I draw a line right there? Does it meet the graph? Obviously it does. So where can I draw a line that does not meet the graph? So one possible line to draw is right there. This line does not meet the graph of f. Another line is right there. See, it barely avoids hitting the curve. So in this region right there, you have lines that do not meet the graph. So I need to identify the boundaries of this region. Where is the topmost point of the region? Obviously there, right there. This is the topmost point of the region. So anything below 1 does not cut the graph. But if I go further down, I shall cut the graph. For example, right here. So I have to identify a boundary, a bottom boundary for the lines that do not cut the graph. And these lines will not cut the graph as long as they are above the maximum point. So as long as I'm above the maximum point B, which is right there, right there, we know that the x-coordinate of B is -1. This is my maximum point in the graph. So as long as I'm above B and below A, I shall not cut the graph. Any line drawn above B and below A shall not cut the graph. And this concept is what I shall use to identify the boundaries of K. Because K lies below point A but above point B. We know that the y-coordinate of A is 1. How do we know that? It's right there. We know that A has a y-coordinate of 1. What about the y-coordinate of B? Well, the y-coordinate of B is not there on the drawing, but we actually got it in the previous question, right there. So the y-coordinate of B is 1/9. So I have to lie below 1 and above 1/9, which is the y-coordinate of B. Hence, the boundary for K is to be between 1/9 and 1. So let's just write that down. So there, these are the answers to A and B and C. Take a minute to look through the answer, maybe write it down if you will. I shall begin question number 3 shortly.